Okay, I have a lot to cover because I think my deadline is 7:15. This is the agenda. I won't be doing the question and answering, although I really enjoy that part of the presentation. Beyond Houdini 11 is going to be pretty cool. And just imagine Q&A, it would be the next presenters, because we have 3 presenters coming on after me. About side effects, this is for the people who haven't or don't know about us. Man, are we different. You can actually talk to us. As a matter of fact, you can talk to me. You can talk to pretty much even the programmers, even though sometimes we don't like that. Trying to stop them is just trying to stop you guys from using the internet at work. So they live, breathe, eat, sleep, dream this industry. And those of us who know us very well know that that's the case. Been around for a long time. I joined in '94. Kim started this thing in 1987. We've even added a reseller in India just recently. For us, that's a big deal. And we're known for procedural animation, and our product is called Houdini. Lots of film studios use us, as I said before. Big hubs in California. We got some in New York, huge in the UK, and spread all throughout the world, even Australia these days. Industry success. I think we only missed 1 year where ILM shut us out, but our customers are in there all the time. And I recently learned even on Avatar, even at Weta, they have a small Houdini team that's usually used to prototype what gets put into the pipeline later on. And that happened with some of the forest stuff, so pretty cool to hear that. And also, of course, Framestone and a couple other companies here in the UK that did that. Games is coming on board pretty fast. They're starting to realize that just plowing ahead and trying to get a game done might not be the best approach, and maybe they want to take a look at this thing called Houdini and its proceduralismness, and they jump on board. And with regards to Houdini 11, key focus is on productivity. And with productivity, there's performance, innovation, and workflow. And I had an RFE list, or what we call requests for enhancements, or SUGs as you might know it. And I trapped them all, and I had over about 30,000, and I gave them to our marketing guy, and he wasn't very happy, because the stuff that I thought was important, he didn't think was important. So, because I'm more about the little tiny things that make the performance a lot better. And speaking of performance, our programmers, or a couple of the programmers, combed all the code looking for really stupid stuff. And you wonder why it took us 10 years to do that, but we actually did that. It's a lot of code. I think it's over 2 million lines now, maybe even more. And we found that, I think what's really cool is that attribute transfer solve actually is real time now with huge data sets, and I think that's awesome. That didn't make the top 10 list though. Flip fluid versus SPH. Flip is great. It actually works like particles, and I really love particles. And SPH is like working with really uncontrollable ball bearings. Power Solver saw a little bit of an increase with threading. So lots of work threading all the operators, getting ready for Houdini 12. As I said, extensive multi-threading and combing through going through the nodes, looking for stupid stuff. Key features. This, believe it or not, was my very, very first flip test over 7 months ago. And I did this in an afternoon as soon as Jeff Lake decided that flip was also pretty cool for doing water, not just sand. And I was dialing in the particle separation. I heard Avatar used a particular piece of software, and I figured, I'll get it down to 4 centimeter spacing. This is actually 1 centimeter spacing over a 40 meter waterfall. Ends up with around 7 million particles near the end, and it only took about 2 hours to sim. And that's when I go, gosh, this is really going to be changing. And this is with the controlling force that the fluid is flowing through, just dialed right up and slowed right down. You can see that it almost looks like flowing lava. And then I have, so I said, okay, fine, loosen it up a bit. This is basically just changing 2 simple parameters inside the scene file. Okay, great, I got it flowing a little bit faster. And then finally, I can actually make it look like muddy water. And of course, I dial it up, and then I move on and do all kinds of other things. This might be maybe a half an hour in my regular day. I'm generating probably 30, 40 files a day, so I'm a ton of stuff. And all this is if I go inside the scene file, I have a train object that's built procedurally. And for those of you who know Houdini, you'll roll your eyes and go, yeah, whatever. But for those of you who are new to Houdini, please put on your nuke compositing hat for a little while. This is not like anything else. These are not node trees. These are not operators. Because for those guys who do know, they're geometry nodes. And this is what I said to you guys what a SOP is. Because for me, proceduralism equals SOPs, or these geometry nodes. We have a simple grid, and we extrude the volume. So the left side of the tree is just my ground plane, and the right side of the tree is the logic that I use to construct the river basin that I then Boolean with my grid, my water basin. And what I want to do is create a field of points with velocity attributes on it, and then pass the fluid through that field. And I want to do that all from the same source. So over here, I have an outrigger basin. And it's passing through this, this network here, which we call VOP, so it's basically just a visual shader building. And if I press forward, you can see here that it's got animated velocity vectors on it that are moving around. And so you can actually very easily add noise. Let's just peer into this guy pretty quickly. And it's just the shader tree. And we can see here there's flow noise, which I really am keen on using these days for adding just really nice non-divergent noise. And I pick up my velocity attribute, and I add the two. And notice how I don't have to lock the geometry before I go into this, so it actually takes dynamic inputs, which is pretty cool. So I'm going to move my display and render flag to the node, a null node called display render. So there's my field. But what I want to do with it is I basically pick it up in here, and I do some pretty cool stuff with it. I actually I do a point cloud, I scatter a point cloud inside of it, and then I add, well, I just reapply the noise to the actual points themselves. So now I got a really nice noisy field that I'm passing my fluid through to get you some really nice character in the fluid itself. So how does that actually work with Houdini's dynamic system, you might ask? In Houdini, we have this separate network where we put all of our solvers and we reference in all of our data. And this is basically, in other applications, this would be black box, but in here we can actually open this up and work at the actual solver level if we wanted to, the microsolver level. And over on the left side, we have our flip fluid nodes. And here we have our static rigid body node, this is a static rigid body object. And there's my particle solver. As I said, you can, this is new for 11.2, by the way, is we've now inlined all the particles. So you can actually start putting your particle rules right in here. We don't do any crazy referencing like we used to do in 10. So you can put your particle nodes right in there. If you had the attractor to do the flip fluid stuff, you know, the stuff with the pulling the water, you can do that as well. And down over here, field force. So I'm going to put on my little old school hat and say, this is the field force stop. And you pass in your dynamic object, which is the white. And the green allows me to add more data to this object. And in this case, I'm binding some geometry to it through a field force. So what it's doing is it's initializing a field force on any object that's passed into here, then I add a little bit of drag. So it's this field force, and this SOP geometry is actually picking up my object water velocity object. And this is bringing in that point cloud with the animated velocity field on it. And then I just go into the field force, and I can scale the force or lower the force if I want. If I want a 0.2 it, and you can now change the behavior of the fluid itself. And you can see the velocities kicking it around a bit. I can turn my velocity flags off, my velocity attribute off. And you just keep on working. You can see how slow it's going. There's probably too much drag. So at any point in time, you can increase this a bit, let's say 0.6, and you can kick it up. And this is such a tunable system that if I was on Skype or WebEx with you, you guys wanted to do more, I could actually put an object in here and say, well, this object, when the particles are in this field, they get more velocity or less velocity. The games begin. And there's drag as well, so I can actually reduce the drag 0.2. And these are the two parameters that you just dial, and you can play around forever. Now, even some existing Houdini users won't know you can do this. You can drag and drop a parameter into the viewport. And that allows you to play around with them right in there if you want to, so you don't even have to see your network. So that's pretty straightforward. Oh, there's one more thing I want to show you. A lot of people are accidentally hitting N in Houdini. And if I go full screen on this, you hit N. Ooh, manually created. Manually created. That means I didn't use the shelf. So what we have now is the N key allows you to see what node was created by what tool or what Python script.